Welcome back, aviation enthusiasts. Today, we're delving into the story of one of the most incredible aircraft ever built, the North American X-15. This experimental rocket plane pushed the boundaries of aviation and space exploration. Let's explore its groundbreaking achievements and the challenges it faced at unimaginable speeds. Developed in the late 1950s as part of the X-plane program by the U.S. Air Force and NASA, the X-15 was designed to explore high-speed and high-altitude flight. With its rocket-powered propulsion system, it was unlike anything seen before. First up, meet the B-52 Stratofortress, a strategic bomber that played a crucial role in the X-15 launch procedure. The B-52 was chosen for its ability to carry heavy payloads and its high-altitude capabilities. To accommodate the X-15, several modifications were made to the B-52. Let's check out these changes. The B-52 was fitted with a special mounting pylon on its fuselage. This pylon was essential for securely attaching the X-15 to the bomber. The B-52's structure was reinforced to handle the weight and stresses of carrying the X-15. This ensured that both aircraft could safely perform the launch. Modifications were also made to the B-52's flight controls to compensate for the changes in aerodynamics caused by the X-15's weight and drag. Now, let's talk about the launch procedure itself. Pre-launch check. Before takeoff, both the B-52 and the X-15 underwent thorough pre-launch checks. The X-15's rocket engines were fueled, and all systems were carefully inspected. Airborne transport. The B-52 would then take off with the X-15 mounted securely underneath. The bomber ascended to the planned launch altitude. The X-15 was carried aloft by the B-52 to a designated launch altitude, typically around 45,000 feet. Once at the correct altitude, the X-15 was released from the B-52's pylon. The release was timed precisely to ensure the X-15 had enough speed and altitude for a successful launch. Rocket ignition. Immediately after release, the X-15's rocket engines were ignited. The aircraft then began its climb to the edge of space, reaching speeds of up to Mach 6. Equipped with a rocket engine capable of propelling it to speeds of over Mach 6.72, about 4,520 miles per hour, the X-15 set the official world record for the fastest manned aircraft. But reaching such speeds came with its own set of extreme challenges. In 1967, pilot William J. Pete Knight achieved a record-breaking Mach 6.72. At these speeds, the X-15 was traveling faster than the speed of sound, 6 times over. But with great speed came intense challenges. When the X-15 reached these extraordinary speeds, it encountered severe air friction. At Mach 6.72, the aircraft experienced extreme heat due to the compression of air in front of it. This heat could reach up to 1,700 degrees Fahrenheit, hot enough to melt many conventional materials. To withstand these temperatures, the X-15 was equipped with a specialized thermal protection system. The aircraft's skin was covered with heat-resistant tiles and ablative coatings designed to dissipate the intense heat and protect its structure. Despite these advanced materials, the X-15 surface still endured significant wear and tear. The constant exposure to extreme temperatures led to erosion of the protective coatings and required frequent maintenance and inspections after each flight. Not only did the X-15 break speed records, but it also set records for altitude. In 1967, it soared as high as 354,200 feet, over 107 kilometers above sea level, entering the edge of space. This was another domain where it had to overcome the challenges of extreme conditions. Many of the pilots who flew the X-15 are celebrated figures in aerospace history. For example, Neil Armstrong, who later became the first person to walk on the moon, flew the X-15. These pilots experienced firsthand the incredible power and challenges of hypersonic flight. The X-15's innovations extended beyond its flight capabilities. The research conducted with the X-15 helped advance heat-resistant materials, aerodynamic designs, and contributed to the development of the space shuttle and other space technologies. Though the X-15 program concluded in 1975, its legacy is enduring. The lessons learned from its missions paved the way for future space exploration and high-speed flight.